Hello, everyone. Please let me know if you can hear me properly. Okay, awesome. Okay, great. Today our session is all about machine learning introduction. I'm wondering, how many of you are coming from data-related background? Any one of you who is either coming from like as a data analyst, working as a data analyst, or you know, um, administrator or something like that, which has something to do with data? Okay. What is your background? Can you please let me know, Wang? Oh, okay. Interesting. So software engineer and data scientist. That's interesting. Okay. The rest. Okay. So Bash. So for
Software
the rest of you, what's your background?
software engineering.
Okay, software engineering. So okay, you are quite, I think, familiar with the okay, so I think all of you are coming from a background which is very much correlated, and it would probably make much more sense. And for data scientists, I think so this one will be pretty easy. The session is all about introduction to machine learning, right? So we want to introduce the machine learning as why it is important, probably, and usually a basic workflow around machine learning, right? And the recent kind of advancements that we are seeing. So I'm just gonna go into a little bit of holistic view of what machine learning is all about and all of the applications that you're seeing, the disruption that you're seeing. And then after that, I'll get into a little bit of more around the particular kind of machine learning workflow. Okay. So let me just get into the whiteboard because all of you are quite, seems like, already familiar with the computer science kind of a programming languages and stuff. So I'm not gonna go into a more kind of a basic presentation over here. Instead, what I really want to give over here is a holistic overview, right? So before we do anything about machine learning is actually a subfield of artificial intelligence, right? So you have, again, any one of you who, again, for the data scientist, I can say that, okay, they have this exposure to AI and machine learning. But for software engineers, for those of you who are coming from computer science background and is working in different kind of areas like DevOps and core software engineers, backend engineers, and so on. I'm just wondering, do you have any kind of experience with AI related technologies? Or maybe you have taken any course? Okay, Copilot. Okay, so it helps you with the code. Okay. LLM, NLP. Okay, I was wondering that. Okay, so a lot of you are coming from a background where you have this introduction to LLM. That's great. Okay. So let me actually give you kind of um a little bit of history of AI, right? So artificial intelligence, right? The first thing is, what is artificial intelligence? Well, the definition is going to be very difficult, right? Because the idea that what can we call intelligence is very subjective, and there is no like consensus. Of course, I mean, there are variety of different definitions, and all of them are true, all of them are correct. um None of them are, I would say, can be deemed as incorrect, but the definition itself is too much, I would say, vague. It's not really specific. So intelligence is in itself, it's a kind of a debate. What should we call intelligence, right? So for that reason, what is artificial intelligence also becomes a little bit of vague kind of a area, right? Um, but still, people have come across different kind of applications where they say that, okay, if you are able to do some kind of planning, right, we call that intelligence, right? Because intelligent people are able to do some kind of planning, right? So that's one area of application which we can call an intelligent application, right? In the same way, you can have something like pattern recognition, right? If you can capture some kind of a pattern, if you can recognize some kind of a pattern, then still you can call that application an intelligent application, right? In the same way, I can list a lot of others as well over here, right? So in the beginning, in 1950s, people kind of, thought that maybe the the expert kind of systems where we have rule-based systems, right? So at the very kind of initial stages, you have these expert systems, okay? And people thought that, okay, maybe these expert systems are actually will give us really intelligent applications. And those expert systems are what? Basically, they are kind of a rule-based system, right? So you have some expert come in and let you know that, okay, to recognize a face, you need to look at these features and that features and blah, blah, blah. If this feature is like that and that feature is like that, blah, blah, blah. And based on that, you make a decision if this is a face or not, right? So that way you could recognize a face. And maybe you are finding out if somebody is having a disease or not, right? So again, you go through that expert system, and that expert system would let you know that, okay, if maybe if you are coughing and your temperature is above 70 or 80, if you're doing this and that, blah blah blah, all of those rules, and based on that you have some kind of a system which would let you know if you are if you are having a particular disease or not, right? So this is what we call expert system, right? Again, I mean, there were lots of applications of expert systems in 1960s. So that was a kind of a major, I would say, not just 1960s, even after that. So in the early era of AI, expert systems were very famous. 1960s and even 70s, expert systems were famous, right? And they were used in kind of airplanes, navigation, and so many kind of areas, healthcare, and so on, right? But one of the major thing there was that you have to hard code all of the rules. And it's kind of AI, but not really intelligent. It's not really learning much things, right? It will quantify some kind of uncertainty and so on, but it was not that much of a big of a deal, right? But still, that kind of brought AI to a lot of people's attention. So like, for example, right now you're looking at GPT and large language models and so on. In the early era, expert systems were like that, right? They created this hype that AI can really be useful in so many areas and so on. So people funded the whole thing a lot, right? That was the beginning of AI, right? But after that, there was this kind of a winter, right? That's what we call AI winter. Okay, it's a famous terminology, by the way, AI winter. And AI winter is when you have you know when you have people losing interest in AI, right? So as I said, people started losing interest in expert systems because of their lack of scalability and so on, right? So then after that, the second kind of a era of AI was about I would call it the perceptron. Now, perceptron is one of the very famous kind of algorithm. Um, Again, neural networks is based upon that. Perceptron is one of the most simplest version of a neural network. And that kind of really kind of, piqued interest of people. Okay, perceptron could be used for intelligent applications. Again, I'm not going to get into the detail of this algorithm. I'm just saying that it's kind of a very basic neural network, one node neural network. And it was a very simple algorithm. But at the time, the idea was very interesting, right? But then somebody came along and wrote a book and said that perceptron is not that attractive as it looks like, right? And they showed that it cannot even solve a simple problems like XOR problem, right? Because it's a linear kind of a model. And that kind of allowed, and that basically, again brought another AI winter, right? So in the beginning, there were expert systems, but then Perceptron came along, and then again, because of because of that book, a lot of people lost interest, right? But Perceptron was kind of a way of mimicking human brain, right? So the idea came from there, right? But again, as I said, after that there was AI winter as well. People did not really do much. Okay, so then after that, in the third era, the statistical machine learning kind of started. People started taking interest in the statistical machine learning. Okay, or statistical learning, you may call it. Okay, that's where you will be learning a lot of machine learning algorithms nowadays, right? So statistical learning is very different. Again, they pose the problem as statistical problems where you have some kind of an input data, you have some kind of an output data, and you're trying to find a mapping from input to output in case of supervised machine learning, right? And you're trying to find out this probability of y given x, right? And you are kind of modeling that, and you're using some kind of a statistical models like linear regression, logistic regressions, and then there came the decision trees and so on, support vector machines, right? And that was very powerful idea, and a lot of people use it for a lot of different tasks, right? That again kind of piqued interest for AI, right? Again, it comes under the domain of AI because it allows you to recognize some kind of patterns. And you have different kind of algorithms in case you have input and output data. And even if you don't have output data, you have only input data, right? So you have algorithms like clustering, you have algorithms like dimensionality reduction, and so on, right? That was another kind of an era, right? But at the same time, people said that, okay, in 1988, for example, there was this algorithm developed called backpropagation, right? And then there were these ideas of RNN and kind of and CNN and so on in the 90s, which kind of was really high end research on these topics around neural networks, but people were not really able to see the hardcore kind of applications for a variety of reasons, right? So so at the same time, in late 90s, you may call it, right? The statistical learning algorithms, which uses the statistics as a base, right? And these different algorithms, which kind of will become the basis of modern neural network applications, started kind of, a lot of traction. So what happened was that there was this kind of a challenge, right? Which you may call it like digit recognition challenge, right? So that challenge was given an image of a digit, right? That image could be the image of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, any digit from 0 to 9, right? Given a human handwritten digit, right? The image of a human handwritten written digit, your task is to recognize if what digit it is, right? So it's kind of a classification task, right? It's an image classification task. Okay, that was kind of a challenge, and people were really interested in solving that challenge in 90s, right? um and usually one of the statistical learning algorithms like support vector machines, SVM, was used for that purpose and was very successful actually, and has achieved a good kind of accuracy as well. But then somebody came along and said that we can modify the neural networks and create this kind of architecture which we called convolutional neural network, right? Which is one of the architecture of a neural network. And they said that this particular architecture is designed for images and can process these images in a really powerful manner. And they showed that this problem can be solved using this convolutional neural network, right? And at the time, they used this all of these other kind of ideas that were also kind of in the process of development during late 1980s, right? For example, backpropagation algorithm and so on, right? So what happened was that the convolutional neural network kind of surpassed the accuracy of SVM, which is a traditional kind of a statistical learning algorithm, right? And that is where I would say the race between traditional kind of a statistical learning algorithm and the modern kind of a neural networks started. I would call that. Again, I'm not gonna, the timeline that I'm giving you is not exact as I'm explaining, but you can get the idea where I'm going with it, right? So after 2000, I mean, the major interest of people who were in the field of AI, okay? So after 2000, I would say um, the main kind of interest was in two different areas, right? One is the statistical learning, the traditional statistical learning, right? And another one was around neural networks, okay? Now, this is a set of different algorithms. It's a set of different algorithms. And this one is kind of different algorithms based on a single idea of neural networks, okay? So a lot of AI researchers started working in both of these areas, right? Statistical learning and neural networks. And people kind of developed AI, right, by focusing on these two particular areas. The expert systems, the number of researchers working in the domain of expert systems and planning. There are other areas as well, which I did not touch because we are particularly talking about machine learning. So I'm not going to get into that, right? But of course, there were people who were looking into other algorithms for planning and reasoning and so on. Again, that's a completely separate topic. That's a completely offshoot of AI, right? As I said, AI is a complicated kind of a beast. It consists of so many different application areas, which can be considered as intelligent application, which is not only about pattern recognition and machine learning. It is about expert systems, planning, reasoning, and so on, right? There is actually again, for those of you who are interested, I just want to kind of name some of the algorithms. There are some heuristic algorithms for optimization. Optimization is one of the area of AI as well, by the way. Particularly if you're not able to get some kind of a convex. If the problem is not really convex, then the optimization becomes really difficult, right? Because you will never be able to guarantee uh, the global optimum at a reasonable time, right? So usually people use the meta heuristic algorithms like simulated annealing. There are so many other algorithms about the optimization, which is called meta heuristic algorithms. Okay. So for those of you who are aware of that, we can have a discussion around that. You can ask me questions around that. I can discuss that, but it has nothing to do with machine learning. Okay, so it's a separate kind of a subfield of AI. So I'm not going to get into that. Okay, so let's forget about the other areas of development that was happening, and let's focus now what was happening after 2000. Right. So there were two different developments happening. Right. One was in the statistical kind of area. Another one was around neural networks. Okay. Now, as we are talking about machine learning, today, machine learning encompasses both of them, right? So I can say that you have AI. Within AI, you have machine learning, okay? And within machine learning, you have all the statistical and neural network based algorithms, okay? Now, to further kind of more kind of create this, a complete diagram, I could say within machine learning, you have deep learning. And this deep learning is all about neural networks, right? So statistical learning and neural networks, all of them are a part of machine learning. But because neural networks is such a special algorithm that there are a variety of different applications, we kind of classify that under a specific subfield, deep learning. which is basically a subfield of machine learning, right? And machine learning is a subfield of AI. Okay? Does that make sense? So over here, you would say that over here, like in this area, you have all of the kind of statistical learning algorithms and so on, right? So you can have all these statistical learning algorithms, right? And that can include all of the I would say supervised algorithms. Again, in machine learning, we will talk about all of them. Supervised algorithm, unsupervised algorithm, semi-supervised algorithm, and so on, right? If we have time, I'll kind of explain them as well, by the way. Okay. So these are three broad categories of algorithms. Now, within these three broad categories, you have different kind of algorithms. Again, I'm not going to get into the detail, but as a bigger picture, you can say within supervised, you have, let's say, two different types. You have regression kind of algorithms. You have classification kind of algorithms, right? So in unsupervised, you also have two type of algorithms usually. You have, let's say, clustering, and you have a dimensionality reduction. Again, I'm giving you a very kind of a broad kind of a 10,000 feet picture, right? In semi-supervised, you have different algorithms. One of them could be considered as recommendation algorithms, right? Again, there are some others as well, which I'm not going to get into the detail, right? So now, again, I can tell you that, okay, there are different kind of a regression algorithms. For example, there is a linear regression, which is one of, very famous one. Probably you have heard about it, even in college as well, right? You have something like decision trees. Then there is some kind of random forest, right? You have, let's say, again, I can name a lot of different algorithms over here as well. And I can name all of the other algorithms as well. The point is, it's not about, again, we will learn about all of those algorithms when we get into, let's say, the machine learning, the details of machine learning. The main idea is, first of all, to let you know the overall big picture of where we are right now, right? So in statistical learning, right, which is all about, I mean, machine learning is consisting of all these different statistical learning algorithms. So all of these comes under that, right? And there is a particular Python package which kind of allows you to kind of implement all of these different algorithms, which is called scikit-learn. Okay. Okay. And I will kind of show you that as well, by the way. Just kind of, show you how easy it is to use this package for your different kind of problems, right? Does that make sense until this point? Is this story making sense? Anyone having any question around that? If you people want something specific, let me know. I can get into that as well. You can send me a message so I can focus on that as well. Right now, my okay, scikit-learn. Okay, I'll get into that. But right now, how does reinforcement learning? Okay, I'm gonna get into that. So within machine learning, you have deep learning, and then okay, I'll create a separate picture for reinforcement learning. Just give me a moment. But for now, let me just focus on the machine learning and deep learning. Okay. So within machine learning, you have deep learning and you have statistical learning and so on as well, right? This deep learning is considered as a separate kind of a subfield, right? This deep learning, as I said, let me get into the detail of now deep learning, which is one of the famous ones, right? So the deep learning is all about neural networks, right? Um, you have different kind of neural networks now, right? The deep learning can be considered as different neural network architectures, right? You have a simple feed-forward neural network, which we called multi-layer perceptron. You can have a particular neural network used for computer vision, right? Which we call convolutional neural network, right? You have another kind of a special kind of a neural network, which is used for language data, right? Which is what we call the recurrent neural network, right? So let me actually rename them and make it more generic. Instead of using CNN, I would say that within deep learning, you have deep learning being applied for the problem of vision, like images and videos, right? You have deep learning being applied for computer vision, right? You have deep learning being applied for tabular data, which is a usual kind of a data sets that you have. It's kind of a structured data set, right? And you have deep learning being used for language and speech data, right? Okay. So these are three basic large kind of areas, I would say, again, broadly classifying it. Deep learning is being used, our neural network is being used for these three different categories of data set, right? Okay, what is tabular dataset, by the way, over here? The tabular dataset that you're seeing over here is a structured dataset, right? You have some kind of input with some features, you have some output, you can organize the data in a tabular form. That's the very traditional kind of a dataset. So that's where you can use the deep learning like algorithm like multi-layer perceptron, right? Now, multi-layer perceptron is one of those very basic algorithms. Um, because the statistical learning algorithms over here, all of them mostly are used for structured dataset like tabular dataset. Okay. Again, that's also a separate discussion as what kind of different datasets do we have, right? So it's a structured dataset, tabular dataset, right? So usually all of these algorithms that I just talked about, the statistical learning algorithms, are applied on a tabular dataset, right? Again, there are so many things that I'm already expecting that you already know about. And in the beginning, when I asked from all of you, like you're coming from software engineering background and data science background, so I'm expecting that. If you don't know about that, and for those of you who kind of joined late, let me know if something is not making sense, if you're confused about it, right? I will kind of get into the details, right? So continuing my just the discussion, the traditional statistical learning algorithms is applied on tabular kind of a data sets, which is a structured data set. Now you can use the deep learning for the similar kind of a tabular data set as well, right? But as I said, the statistical learning algorithms has supervised learning algorithms, unsupervised learning algorithms, the semi-supervised learning algorithms. Interestingly, that's why deep learning is a separate subfield. That's why deep learning is a separate subject, right? Because you can use different neural network architectures to solve different kind of problems like supervised, unsupervised, semi-supervised, and so on, right? Some of the examples would be you have a multi-layer perceptron, you have autoencoders, right? Autoencoders is for unsupervised, by the way. You have, again, I'm not going to get into too much details, but you have, if you are aware of it, if you can, research about it, you will find it out. You have Boltzmann machines, right? So these are all different kind of neural network architectures that can be used for these different problems. There are specific, kind of, neural network architectures for recommendation as well. That's what we call recommender systems and so on, right? So whatever we touch upon, whatever we look into, the kind of traditional statistical learning, you can solve it using neural networks by using different kind of architectures, right? That's why neural network is so powerful. You can create an architecture which can solve your any kind of task, right? Depending on whatever task you're interested in. Okay. So these are different kind of architectures, okay, which will be used for tabular dataset, okay, mostly, right? Now, let's look into the vision dataset. That's really interesting because now this is a separate kind of a dataset. It's in the form of images and videos, right? How do you process the images and videos? It's not a tabular dataset, right? In tabular dataset, the main feature of a tabular dataset is that a single row will represent a single sample, right? And the different columns of a table would represent different features of that sample, right? So a single row would be a single sample. Different number of columns would represent different features of a sample, right? In case of images and videos, right? What is a sample? Sample itself is kind of a 2D array, right? So how do you convert it into a single row? You can still kind of convert it into a single kind of a row by flattening it. but it's not really optimal use of the information that exists within image, right? Image contains this spatial location information, right? Again, it's a really specific thing which comes under the computer vision. So computer vision itself has become a separate big field, right? Which involves a lot of different problems, right? Related to images, right? So you have, let's say, image recognition, you have object detection, you have image segmentation, you have image enhancement. There are so many things that you need to do on the images, and there is a lot of data which is related to images and videos, right? So it's a separate field, right? Solving all of these problems using a traditional kind of a tabular setting, using a traditional kind of algorithms, is not that powerful. Instead, there is a specific kind of algorithms in neural network, specific architecture of a neural network, which is being used for that purpose. That architecture is called CNNs, convolutional neural network, right? And within that convolutional neural network, of course, as I said, you have variety of different problems related to images like detection, segmentation, and so on. So again, there are variety of different kind of algorithms, right? So again, if you know about CNN, you will understand how we can modify the CNN to solve different kind of problems, right? So for example, you have algorithms like YOLO, you have algorithms like UNet, you have architectures like InceptionNet and so on, right? Of course, you have a transformer-based architecture as well. Okay. So again, vision transformers and so on as well, right? So these are all different kind of variations of CNN used for different kind of images related tasks. Okay. And all of them uses special neural network architecture, right? And this is where deep learning and neural networks shine. Why? Because traditional statistical learning cannot be used for that purpose. Okay. Now, within the deep learning, you also have the data related to languages and speech, which is also very different, right? Again, you have language, which is a sentence, and you have different length of sentences. And let's say you want to classify every single sentence, right? How do you convert it into this kind of a tabular setting? If you do that, it will not be that kind of a powerful idea. Because again, as I said, in images, you have a spatial location, spatial information, spatial kind of a pattern that you want to capture. In the languages, you have a sequential information because every next word is dependent on the previous words, right? So capturing that kind of information, right, is not feasible using tables, right? Using a traditional kind of a data structure, right? So instead, there is a special neural network which is used for processing languages and speech, right? And those, again, architectures can be categorized into, recurrent-based neural networks, which are basically LSTM, GRUs, and so on, right? But then there is another kind of architecture which was kind of introduced in 2017, which is called transformers. Okay. Now that changed the whole game, right? So I'm not gonna, again, there is so much that I want to talk about, but we don't have much time where I can give you the whole history and stuff, right? All of them requires a separate lecture where I can give you the history of NLP and LLMs and so on, right? But transformer is the basis of LLM and so on, right? And that was developed or introduced in 2017, right? Although the motivation existed in 2015 as well, nevertheless, right? But the point over here is that you have separate kind of neural network architectures, which is trying to solve this kind of a language and speech kind of a problem for you as well, okay? So now, if I have to kind of give you a kind of a quick summary, right, over here, the AI, the boom of AI, I would say that the craze of AI nowadays can be categorized into two basic areas, right? I would say the computer vision and natural language processing, NLP. Okay. Now, why didn't I start directly with this slide, with this kind of a notion? The reason was I wanted to let you know that where are we right now? the computer vision and NLP, both of them uses what? Neural networks at its core, right? And that's a part of deep learning. So I can say that deep learning is the major reason for all the craze of AI. Okay. And this deep learning has special kind of neural network architectures for different kind of tasks related to vision and NLP and so on, right? And deep learning itself is based on a single algorithm called neural networks. And when we get into the neural networks, you will know that neural networks itself is based upon logistic regression. Okay. And that logistic regression is a traditional kind of a statistical learning algorithm, which can be understood by looking at a linear regression, which is one of the most simple algorithm, right? So from linear regression, we learn logistic regression. From logistic regression, we learn neural network, which is the basis of deep learning. And from there on, we learn, okay, how we can modify neural network for the computer vision and for the NLP, okay? By looking at the specific problems related to computer vision and NLP. Make sense? So generally, to understand whatever is happening right now, you need to understand the deep learning. And to understand the deep learning, you need to have a good understanding of our traditional statistical learning algorithms, right? Because they make the basis of it, right? So you need the machine learning overall, which consists of statistical learning and deep learning as well. Okay? That's the main point. Now, I will show you the scikit-learn, which somebody asked. And also, let me kind of answer the question somebody asked about the reinforcement learning. But before I do both of these things, I'm just wondering if somebody is having any question around what we just discussed. So is TCN part of CNN? So what is TCN? Temporal. Okay. So again, temporal means that you have, um, again, it's, you can, there are convolutional neural networks which takes into account the temporal aspects of data as well. It's a specific kind of a neural networks, and you can combine again because videos itself has this kind of a sequential nature to it as well, the temporal nature to it as well. So there is a specific algorithms which we'll look into separately in the computer vision, which you will see that okay, there are some algorithms which takes into account both of these aspects together as well. There are algorithms. Yeah. Okay. And by the way, just to kind of give you another aspect, computer vision itself is not a new kind of a topic. It's not like deep learning application has made this possible. There is a traditional way of doing computer vision as well, and there is a traditional way of doing this NLP as well. Okay, and that traditional way does not take into account the neural networks. And usually, the traditional NLP and traditional computer vision algorithms are not that good. It's just that applying big neural networks allowed us to kind of solve different kind of problems in that domain, which makes the deep learning even more desirable and more kind of people are more interested in it. Okay. Okay. So now to answer the question about reinforcement learning, right? So reinforcement learning is a different kind of an algorithm because the statistical learning and the deep learning kind of algorithms would try to solve a problem where you have some kind of a static data set and you're learning some kind of a patterns from it, and then you are kind of predicting for the new the new coming data set, right? You learn some kind of a patterns there, right? In reinforcement learning, the whole process is really different, where you have some kind of an environment, right? And there is an agent, okay? That agent can be a human, it can be anything, right? This agent interacts with an environment, okay? it takes some action. This agent takes some action in this environment, and based on the action, this environment will give as an output some kind of a reward, right? That reward could be positive, could be negative, right? And because this agent took an action, this environment also changes, right? Now, because the environment changes, and based on that reward, this agent will learn if my action was a good action or bad action, right? And then next time, this agent would take another action where it would try to make a good move, right? To take a good action such that the environment changes in a positive manner, right? Now, this is a very generic way of kind of saying the whole process, right? This is a generic kind of a setting of reinforcement learning where we are learning how to take actions in a particular environment, right? Let me give you an example. So I'm not really sure how many of you have watched the documentary AlphaGo. If you have not watched it, I would strongly recommend to watch it on Google, on YouTube. It's by Google, where they show that the one of the most kind of a complicated game, which is called Go, was kind of played by an AI agent developed by Google, and it kind of defeated the kind of a world champion, right? The human world champion. And it was a big breakthrough, right? Because this Go game is extremely complicated game, right? And it has billions of different moves, right? Learning how to make in action, what action to make and where to move your kind of, whatever you're playing with is extremely difficult, right? Learning that pattern and behaving in that environment is extremely difficult because you can make billions of different moves, right? So they use the reinforcement learning with deep learning, right? So reinforcement learning is another way of learning from an environment about your action. But because there is a learning part in it, you need to learn using some kind of an algorithm. And recently, after 2016 and 2017, people started using deep learning, or you can use any other machine learning for that purpose, by the way, for learning purposes, right? Again, as I said, the formulation of a problem in reinforcement learning is very different, okay? Which usually you might not see. In kind of robotics, you would see that a lot, and games and planning and so many other things. Usually companies don't use reinforcement learning a lot, right? But those companies who are using reinforcement learning, they're not using it just kind of a separate entity, right? There are specifics related to reinforcement learning, which you need to know, right? There are algorithms related to reinforcement learning as well. But there is this learning component for which you have to use a deep learning or a statistical or traditional kind of a machine learning as well, right? It's not like it's a separate kind of a component, okay? It's not like, oh, you can't use machine learning or deep learning for that. It's just that machine learning and deep learning is used for specific pattern recognition kind of task. Reinforcement learning is used for completely different kind of tasks. However, while learning in those different environments, it makes use of deep learning and machine learning algorithms, okay? And that makes the reinforcement learning even more powerful. Why? Because deep learning is very good at vision and images and videos and language and speech and so on, right? And usually, if you look at the environment, the actual human environment, if you look at a human, most of our data comes in through some kind of a sound and some kind of an images, right? Consistently. And the beauty of a human is the human intelligence is because we can process the images data really quickly and with too much of accuracy. That's why humans are so intelligent in behaving in different environments, right? Imagine if you have robots which learns to behave in different environments, making use of these deep learning algorithms, It's a great combo, right? So that is what is happening here. My point over here is not to get into the details of what reinforcement learning is, but I hope so I was able to kind of explain that to you. Just to give you a little bit of more concrete example, you can look into a game of chess, right? So what is a game of chess? You have some kind of an environment, right, where you have different kind of moves, right? You have environment where you have different kind of things placed at different location, whatever locations you have placed your stuff, right? That would be your environment, right? You will make a move, that is what we call action, and that move would change your the environment, right? Because you have moved your let's say your king or your queen to the left, let's say, right? So definitely it has changed the environment, right? But again, you will also get some kind of a reward, and that reward will be the probability of win, right? Because at the end of the day, what do you care about? You want to win this game, right? So you have to kind of find out in this particular environment, given that these are the locations of different king and queen and blah, 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 what is your probability of a win after making this move? If your probability of win increases, it means the move was a good move, right? In that particular environment, right? Otherwise, it was a bad move if it reduces your probability of a win, right? So you learn these probabilities and these moves, right? And at the end, you become so good that you know how to, what move to make, what action to take in different kind of environments, right? And this learning process, right, uh, is done through machine learning and deep learning and so on, right? Does that answer your question? For those of you who asked the question. Oh, okay. Okay, perfect. You're welcome. Now, generally, again, as I said, there are lots of different algorithms to understand the overall AI and overall applications of AI for today. You have to kind of, get into the whole detail in a very kind of a, sequential manner, from linear regression to all the way up to all of these algorithms. You need to kind of learn all of those. Otherwise, it will be a broken pieces. You can look into some algorithms, but for that you need to learn some other algorithms and so on, right? So it's very important that you go through that whole process in a very kind of organized sequential manner. Okay. One last thing before I move on, because a lot of you are interested in LLM and NLP, right? I just, again, I mean, although we don't have much time, maybe we can have a separate session on LLM. But the LLM itself is the application of NLP, right? Um, where which was created because of this transformer architecture, right? So in 2017, first time somebody kind of introduced this new architecture called transformers. In the paper, the name of the paper is called Attention is All You Need. Okay. You can read that paper, Attention is All You Need. It's a really good paper. And within that paper, they discuss this special kind of a neural network architecture, which allows you to do the parallel processing and really process the long context. It kind of solves almost all of the problems that existed before 2017 in processing languages, right? And itself, it was really fast and so on, right? It kind of, completely opened a new gate, right? After that, people took that architecture and took a lot of data from internet. Okay. Consider all of the data from internet, like lots of books, blogs, everything that exists on the internet. Imagine that, right? You took a lot of data and created a very big architecture with billions of different parameters, right? So you have a very big compute power. You require a very big compute power, right? And a lot of data from internet, right? And when you combine them together, you kind of train the architecture with billions of parameters and a lot of data on internet. You're able to learn how humans understand language. What is a large language model? It is a model which predict for you what is going to be the next word, given that you have already explained kind of few words back, right? So it's a next word prediction model in a way, right? Again, it requires a separate whole discussion, why it is so famous, why it is so useful, and so on. So that's a complete separate discussion. Right now, I think it's not possible for us to cover it today. Okay. So somebody did ask, I find deep learning is hard to understand with the same way to learn traditional machine learning methods. Should I focus on the architecture when study deep learning? What is the best way to understand deep learning? Well, I would say that if you need to understand deep learning, you need to first of all understand the deep learning for a traditional kind of tabular methods, how the deep learning is used for tabular methods, different architectures there, and try to understand how deep learning works, right? And for that, if you understand the machine learning, I think so it will be very easy for you to understand the deep learning. For example, again, I'll give you just a single example where you have, let's say, linear regression. What is linear regression? Basically, there is a model which is what we say y equal to mx plus c with one input feature and one output feature, right? The task in linear regression is to learn the m and c, right? And how do you learn that? Well, you will have to take the partial, again, you need some kind of an error metric. Let's say that error metric is mean square error, right? You will have to take the partial derivative of that mean square error with respect to m, right? And you also have to take the partial derivative with respect to c, right? And once you found that, then you use the gradient descent as an optimization algorithm for that purpose, right? If you understood even this linear regression in this manner, the mathematics around it, the details around it, right? I can assure you that you will be able to understand the traditional kind of a multi-layer perceptron as well, right? And once you do that, you will be able to understand the autoencoders and all of the other different kind of architectures, right? And the moment you do that, then pick one of the area, computer vision or NLP. Within computer vision, start with simple CNN and then try to understand the history of it. For example, you have CNN, which was even developed in 1990s. But then, and there was a specific architecture of CNN in 1990s, which is called LeNet. Then there was LXNet, right? Then LXNet was in 2012, by the way. This was probably in 1998, right? And after LXNet, there was a lot of other architectures as well. So I can say that there was GoogleNet, right? There was ResNet, right? These are all very important architectures, right? This GoogleNet is also called, by the way, InceptionNet as well, okay? So you have UNet, right? You have YOLO, right? You have Vision Transformer, right? And again, I would encourage you to understand, first of all, the timeline of different architectures that was developed and try to understand why they were developed, what was the motivation behind it, and so on, right? So that would help you understand the CNN. And the same way you can go for the natural language processing as well. Okay? Make sense? Any good book to record to learn this history? Well, you have a deep learning traditional kind of a book, academic book, which is very well famous by MIT and MIT Press, I think, are by Cambridge, I think. I'm not really exactly sure. There are a lot of books around that. You have computer vision related books as well, but I would encourage you to read Medium blogs as well. And probably we can have a separate session on that as well, like history of computer vision algorithms and so on. In that, I can also kind of give you a little bit of explanation around that. But you can read online articles as well, blogs as well, and that would also help you. Okay. Anybody having any question around that? Perfect. If you don't have any question, I would encourage you to go through our offerings that we are offering. There are self-paced material that we are offering where we have all of these different kind of pre-recorded videos which you can get into as well. So please do look for that. And yeah, if you have any question, you can contact us as well. If there are no questions, yeah, have a good rest of the day. And yeah, perfect. Thank you, everyone. So the recording can be found at YouTube channel. I think, yeah. Adam just shared that. Let me just share it again over here. Thank you, everyone. Take care. Bye-bye.